Hello everybody, welcome. My name's Alex Pett. I'm a product manager within the Ansys Physics business unit. And I've been invited to speak to you today to really give you a bit of an introduction to Ansys and who we are, to break the news to you already, if you didn't already know, that Ansys has acquired LSTC, and to have a little bit of a look as to how these two companies fit together and where we see these two product lines going in the future. So, without further ado, in case it had escaped your attention, on the 1st of November 2019, Ansys acquired Livermore Software Technology Corporation, LSTC, the creators of LS-DYNA. But this wasn't an acquisition that came out of the blue. This is an acquisition that is really a culmination of 25 years of partnership together, and hopefully what we have found is a natural home for LSTC now within Ansys, and we can look forward to what's to come in the future. So I suspect this leaves you with many questions. Who are Ansys that have come along and acquired LS-DYNA and LSTC? What plans do they have for that product and the ecosystems in which it can exist going forward? And hopefully I'll be able to answer some of those questions for you today. So who are Ansys? So Ansys were founded in 1970 by a man called John Swanson. We're headquartered in Pittsburgh over in the US, and we're floated on the NASDAQ. We're a public company with our stock tracker as ANSS. We like to brand ourselves as the world's largest dedicated engineering simulation software provider. So there are many other simulation software providers in the world, several of whom are larger companies than we are, but they typically do many other things apart from simulation. Ansys simulation is our lifeblood. That is all we do. We offer a range of simulation tools that span multiple different physics areas to enable our customers to effectively design better products, to create products that go out and thrive in the real world first time. We are currently just over 4,000 employees spread across the globe in 75 or so different offices. And a very important part of the Ansys history has been that throughout our time as an engineering simulation software company, we have been what we term CAD agnostic. So we do not create our own CAD system, we do not create our own PLM system, and we do not enforce our customers to work with any particular CAD or PLM system. Effectively, with inside our tools, we can read in CAD formats from all of the major manufacturers, all of the major formats, and work with those seamlessly. It doesn't matter where they come from. So that agnosticism when it comes to the source of your geometry and your parts within analysis is something that's very important to Ansys. And it goes very much along with our open ecosystem ethos that we also have, and I will talk about. So in terms of how did Ansys get to where we are today? Well, like I said, we were founded in 1970. And really from the year 1970 up until the year 2000, all we did was structural mechanics simulation software. We were well known for a product which at the time was just called Ansys, now referred to as APDL, the Ansys Parametric Design Language. And this is an implicit FEA analysis tool that really was started back in 1970, so 50 years of pedigree to it. And that was all Ansys was really up until about the year 2000. Since then, we've really been on a very sharp growth trajectory, both through organic growth and also through acquisitions and mergers. And that started really with the acquisition of Fluent back in the year 2000, which got us into the world of computational fluid dynamics. We then moved on to acquire companies like Ansoft and Apache that did electromagnetics and semiconductor design, respectively. And the rest is really history. The acquisitions have come thick and fast since then, and that has really given us the ability to offer a full portfolio of analysis tools to our customer base. from structures, fluids, electronics, optics, materials, optimization technologies, and all the way through to the end of that graph you see there in the acquisition of LSTC back in 2019. We also partner with some of the large enterprise providers in this space, so companies like PTC and their Creo tools and SAP, to enable a broader spread of people to use analysis tools. And really the Ansys ethos behind its 50 years of existence has been simulation-driven product development. And that's gone through various different names and incarnations, from pervasive engineer or pervasive simulation, as we call it today, through to virtual prototyping, as we called it 20 years ago. But really the ethos is the same, enabling customers to create products that go out and thrive in the real world through the use of simulation technology. So that series of acquisitions over the last 50 years has really allowed us to offer a very comprehensive and broad simulation suite. Whatever the area of physics you wish to simulate, there will likely be an Ansys tool to help you do that. But it is not just the breadth of our simulation that is really important to us, it's the depth of that simulation as well. So the accuracy and the quality of those individual solvers is something we really pride ourselves on. You know, robust quality assurance, robust regression checking of these solvers to ensure that they perform as best as they possibly can. We also like to see ourselves as an expert partner to our customers rather than just a provider of simulation technology. So we advise these customers on how they can use simulation better and more efficiently within their organizations to improve productivity, improve quality, and drive down cost. And then, as I alluded to earlier, very importantly for us, we offer an open ecosystem. So all of the Ansys tools are able to be customized, and through that customization, it means customers can include Ansys products into their workflows or include their workflows into Ansys products in a very flexible and open manner. And indeed, that's particularly relevant for the session today because LS-DYNA and the integration of LS-DYNA into the Ansys Workbench environment was done as a customization through this open ecosystem originally. It has evolved since then into a fully development-owned, quality assured piece of software. But the open ecosystem is really what has driven a lot of our developments and direction over the years. So the Ansys acquisition of LSTC, like I said, was by no means an out-of-the-blue acquisition. The relationship between Ansys and LSTC is something that has run very deep. We have over 20 years of partnership with LSTC, effectively OEMing their solver technology into our environment. Originally, you can see an example over there on the right there from the mid-1990s. That was into the Ansys APDL environment. Nowadays, we don't use the APDL environment for pre and post, although of course the APDL solver is still very, very much alive. We now have LS-DYNA integrated into the much more modern Ansys Workbench and Ansys mechanical ecosystems. But you can see that story of collaboration goes way back. And indeed, it's not just us OEMing their technology, their LS-DYNA solver into our portfolio. LSTC and Ansys partnered on sparse solver technology development back in the early 2000s. And you can see these technical relationships have therefore been established for a long time. The integration of LS-DYNA into the Ansys Workbench and mechanical environment that we see today, that started back in 2008, as I said, as a customization originally, but it was brought into the Ansys development organization about 5 years ago. And that is really what led to, I suppose, the acquisition of LSTC in 2019 was the success and growth of this Ansys LS-DYNA Workbench enabled product. So what we hope is that we have found a very natural home for LSTC now. If you've kept up with the world of engineering simulation over the past 5 years, it's really been a story of acquisition and merger with these larger companies buying up the smaller companies. And if that was going to be on the cards for one of our close partners like LSTC, the only home for LSTC really was with Ansys. And John Hallquist, founder of LSTC, very much agreed and was on board with that as well. He could see the potential of the power of the LS-DYNA solver combined with the openness and the flexibility of the overall Ansys ecosystem could really create something very, very special. We both have large development organizations of world-class scientists, and we really are working hard on creating synergy between those two development organizations. And ultimately, Ansys and LSTC were both customer-driven organizations. Customers were central to what we did, what we do today. And both John and Ajay, CEO of Ansys, were very much agreed on this point. So if Ansys had a motto, it would be pervasive simulation is what we do. As I said before, we once spoke about virtual prototyping. Then in the 2000s, we spoke about simulation-driven product development. Now we talk about pervasive simulation. What that really means is simulation across the entire product lifecycle, not just in the design and analysis stages that we might have been used to in the past, but all the way through from the creative phases, what's labeled here as the ideation stage, all the way through to the detailed design that we know, and then on to the manufacturing and the manufacturing processes, the actual in-product and operation of these products. And obviously LS-DYNA has a large part to play in these areas, particularly when you talk about the manufacturing and particularly when you talk about the end product. Now, as data that we can gather from products out in the real world has increased, the viability of running true digital twins of these products using your simulation models but driven by real world measured data is now a reality that companies are doing in order to predict maintenance, reduce operating costs, reduce downtime through prediction using real world data. So pervasive simulation across an entire product life cycle really is the mantra that we march behind. And we can offer that pervasive simulation because we have such a broad spread of tools and capabilities and products behind us. So through our growth and acquisitions, like I said, we have been able to move into provide offerings in the world of not just structural mechanics analysis, but fluid dynamics, electromagnetics, optics and radiation design, semiconductor design, and being able to tie all of this together into a holistic systems level model that can represent all of these world-class individual physics solver engines tied into an overall system. Because as we know, as products have got more complicated, you can't just look at these two products in a single physics world. You need to take into account the structure, the cooling, the electronic performance, the semiconductors, the sensors and optics, the embedded software and system control algorithms that you run, and combine all of that to run full systems analysis. Also through our materials capabilities, so through our Granta Material Intelligence, Granta Selector, Granta MI Pro and Enterprise products, we enable customers to store, manipulate, control and retrieve material data efficiently across an entire organization, not just for the purposes of simulation, but for all the other purposes companies need to track material data for. Tracking of billing of material costs, tracking of reliability of supply, of environmental footprint of particular materials that they choose to use. And then all of this is really overlaid by the Ansys platform, which is you could define as the ability for all of these tools to talk and communicate with each other. And that really is the open ecosystem that I talk about. And all of that, of course, is now either already or becoming available on the Ansys cloud. Desktop computing really is what Ansys and LSTC have utilized to their full extent over the past 30 years. But the age of desktop computing is shrinking. The age of remote compute resources and cloud compute resources is growing, and Ansys is very much on board with that. So whether you look at overall industries or simulation or industry megatrends, as you might call them, Ansys is present in pretty much all of the industries that you care to mention. It's hard to find an industry where Ansys doesn't have a presence in some way or another. So if we take a bit of a deeper dive into the actual Ansys structures family, because this is where LS-DYNA now resides. So we already had a broad range of products, and indeed, LS-DYNA was a product we OEM'd and sold before the acquisition. So this range of mechanical analysis products really does look the same as it did pre-acquisition, except now, of course, we're talking the complete LS-DYNA solver and all of the technology that goes with that. So all of those products you see there on screen for structural mechanics analysis and fatigue analysis and electronics reliability are all linked to our materials information systems. So you can use consistent material models and material data across your analyses. And all of that together and tied into the systems level simulation is what we would call our structures offering within Ansys. And as I say, that is now the new home of LS-DYNA. So you may then ask the question of, well, how does that fit with LS-DYNA being a multiphysics product in its own right? LS-DYNA has fluid solvers, structural solvers, electromagnetic solvers. And how does that fit with Ansys already having these? What is the plan for these solvers within DYNA? Well, I can tell you that we have absolutely no intention of stopping development of these tools within LS-DYNA. One of the major reasons there was the acquisition is because Ansys could really see the potential of the multi-physics solver capability of LS-DYNA. That single solver, single license, true multi-physics mantra that John Hallquist always expanded is something that we very much want to keep going. Of course, we can see big potential for crossovers of that technology between our flagship structural fluids and electromagnetic solvers and what's available in DYNA to enhance both of those solver systems. But ultimately, the holistic nature of DYNA and the capability for it to run these strongly coupled multi-physics simulations is very central to its future within Ansys. So, understandably, as the LSTC user base, there may be questions or concerns that you have had over the acquisition of LSTC by Ansys. And I'm hopefully here today to reassure you about the future of the LS-DYNA solver technology and how that fits within the Ansys environment. So, like I said on the previous slide, we very much want to continue the great work that John and the team in Livermore have done over the past 40 years. So we intend to continue the current development trajectory of LS-DYNA. The projects and technologies that they were researching before acquisition, we will be continuing researching and developing. We intend and want to integrate and work with the LSTC partners, so people like Arup that have brought us all together today. We are very excited to be working with these companies, and these companies are now part of the Ansys family, I would say. But having said that, that of course brings up go-to-market questions and how do customers go. Who do customers go to purchase products or support? And all of those relationships really will very much continue as they did before. Customers that came to Ansys will continue to, customers that went to our partners will continue to go to those partners. And similarly, we very much intend to continue the partnerships with the other pre and post processors available for LS-DYNA. Specifically in this case, the Oasys product suite. We see that as very important to Ansys and our customers going forward. Similarly, tools like Ansys and Hypermesh and the relationships that LSTC had with those companies, we are very much wanting to continue. We also would like to reassure you that we have no plans of breaking this LS-DYNA tool apart or asset stripping it in any way. It will continue as a single solver, single license, true multi-physics tool, and we will not be force migrating you away from that tool. You will be able to carry on using LS-DYNA in the way that you see fit. Having said that, we will of course be integrating LS-DYNA even deeper into the Ansys workbench and mechanical environments to enable it to talk and communicate with other Ansys tools and to work inside of that open ecosystem of which I spoke. And there's interesting work going on hooking up DYNA with Python control, for instance, at the moment. And of course, we're very keen on seeing spread or synergy between the LS-DYNA solver and the Ansys solvers that we already have in our stable. So those solver and development teams are working closely together to try and pull the best of both worlds of Ansys and LSTC together into our technology going forward. So in terms of the roadmap of where is LS-DYNA going over the next few years, well, as I said, we have no intentions of significantly or drastically changing the development trajectory that was already planned out for LS-DYNA. We do very much want to consolidate all of our modeling technology together into what we would like to call a common model approach, so that a single setup can be utilized for equally well for an LS-DYNA analysis or for an Ansys structural mechanics, whether that be linear or non-linear analysis. So this one model for crash, NVH and durability is something we are working and researching hard on at the moment. We also have a new metal stamping vertical coming along later this year. So this is something again that the team at LSTC had been working on before acquisition, and we will be bringing this to market hopefully towards the end of June this year under the name of Ansys Forming. Looking out to the longer term, there's some interesting technology available within the LS-DYNA stable that we would very much like to bring to market. IGA being one of those, the isogeometric analysis technology. It's an area we had been working on, it's an area that LSTC had been working on. We see it as a potentially groundbreaking change in the way people use finite element analysis, and there is a lot of research and development going on between all of our development teams and our geometry teams on how IGA could make its way into the public domain. And ultimately, we see great potential with LS-DYNA tied into the wider Ansys ecosystem and our systems and statistical analysis tools to enable digital certification in the future, whether that's for medical devices or medical procedures, or whether that's in the automotive industry or the aerospace and defense industry. But we think digital certification has a great future ahead of it. We've already done the digital product development. Well, digital certification or digital testing is next. Digital certification we see as one of the key next areas. It's worth also just mentioning cloud. Cloud is something that gets increasing attention both within the engineering simulation world and within Ansys. Ansys now have a cloud offering available, and the Ansys LS-DYNA product is already available through that. The next release of our technology at the end of June will also see the release of DYNA R13, and that will include capabilities to connect Dyna to the cloud and some back-end licensing work that needed to happen. But that will basically mean then that all versions of LS-DYNA become available on the Ansys cloud, and bits of the supporting technology that go around those also being available, so things like LS pre-post. So in terms of just some roadmap highlights to begin to wrap things up, I don't intend to go into any great detail here on the roadmap as we see over the next couple of years. And indeed, as I say, a lot of this technology was already planned out by the team at Livermore before acquisition. So things like the 2-scale simulation, enabling you to co-simulate a global scale and a local scale model together. That's going to come to full release later this year. The battery modeling module within LS-DYNA, again, is already there at some level, but there'll be additions to that coming at the R13 release. But of course, we are also aiming to couple and connect LS-DYNA better to Ansys tools. So things like FenSap Ice, which is one of our tools we use for looking at icing accumulation on leading edges of aircraft wings and engine nacelles. Obvious capabilities of connecting that to LS-DYNA for looking at ice ingestion modeling. We had our own explicit analysis tool called AutoDyne, which came very much from a defense background, looking at blasts and explosions and ballistic events. And we're looking at combining that and the LS-DYNA solver together into a single offering, effectively building AutoDyne into LS-DYNA as a series of new keywords. Electronics is a very important area for Ansys, and LS-DYNA is going to be central to our strategy for electronics simulation going forward and electronics reliability. So linking LS-DYNA with our tools like Sherlock for bringing across electronic components and electric traces and PCBs is going to be a big area of work. The cardiology research with the FDA, looking at the sort of 3-way coupled mechanics, CFD and electrophysiology, is work that's going to very much continue going forward. And all in all, just better coupling and communication between LS-DYNA and the other Ansys products, as well as, of course, development of those individual DYNA solvers, things like IISPH, the incompressible CFD solver, CESE solver. These are all going to carry on their development trajectory, but with closer work and support from the other Ansys flagship solver product teams. So there I would like to wrap up. It just really leaves me to thank you very much for your time, to thank Arup for hosting us today and inviting me to speak to you. And really, I would just like to say welcome to Ansys, welcome to the Ansys user group, and welcome to the Ansys family, and that we would very much like to hear from you. Like I said, we are a strongly customer-driven organization, and what our customers are saying to us really does affect the way the software evolves and changes as we go forward. So I look forward to working with you in the future, and I hope you enjoy the rest of this Arup event. Thank you very much for your time.